Alright, so today's lesson is on symbolic logic. We're just going to be talking about the basic concepts of symbolic logic, basically the vocab words that you guys need to know, and some truth tables, alright? So, the first thing you need to know is proposition. That's a statement that is either true or false, alright? So, for example, today is Monday, which is true, right? It is raining, and I don't think it's raining, so it's pretty false. And 4 plus 5 equals 10. That's not true, so I guess it's false. But these are statements that you can say it's either true or false, alright? Examples of non-propositions would be, is it Friday? Like the question mark, like that's not a proposition, that's not a statement, it's more of a question. Take out the trash, that's more of a command. And 2x plus 1 equals 9. We don't know what x is yet, right? So that's not really a statement that's true or false. Alright, just to refresh notations, our statements are usually denoted by letters starting with P, and we're going to represent P to represent some statements. So for example, P equals today is Saturday, right? Negation we've already talked about in the last section. These two, we're going to denote that it's going to be not P, or the negative of P, right? I think most of the time the IB users use this one, but I like to use this one because it's just, I don't know, easier for me to write, but whatever. Sorry. So not P is the negation of P, right? Not P has to always have the opposite truth value of P, and the truth value stuff we're going to get into in just a little bit, alright? So P equals today is Saturday, not P is today, sorry, is not Saturday. Alright? Not is the important word. Do not put not P, today is Monday. That would be wrong. That's another statement completely different from what P is, and it's not saying that's the negation of it. It's just telling you, like, it's today is Monday, right? Today is not. This is very important. Every time you deal with negation, you're going to be saying not whatever, all right? Not. Do not write some other type of statement, all right? Truth value tables, I need you guys to copy this down. If you need to pause it, go ahead and pause it, but leave 2 blank spaces here, all right? So for the truth table, not P is basically the opposite. So if P were true, then not P would be false, right? What the? Well, not P would be false. If P were true, then not P would be true. I mean, sorry, if P were false, then not P would be true. Right? The exact opposite. So again, if P equals today is Saturday, then not P is today is not Saturday. Alright? And again, do not say not P is today is Monday. This is wrong, alright? Please do not do that. Remember, that would be just another statement, alright? The word conjunction means and the notation for that is that little triangle symbol without the bottom base, right? And this is read P and Q is true if and only if, right? And remember, this is if and only if is true, and P is also true. So if we're looking at the truth table, and this is what we're going to get into more so in the next section, P and Q, these are combinations of true and falses that they can have together, right? Both can be true and true. P can be true, Q can be false, P can be false, Q can be true, P can be false, and Q can be false, right? And if you see this pattern, this is always going to be true, true, false, false, and then this is always going to alternate true, false, right? Once we have another third column with R, the pattern will be totally different, but you'll quickly see that, or I think they'll actually give that to you. So anyways, the rule for this is that P is true if and only if, or I'm sorry, P and Q is true if and only if P is true and Q is true, right? So if P and Q are true, then this has to be true, right? If P is true and Q is false, then this is gotta be false. False, true, gotta be false. False, false, definitely gotta be false, right? So again, they both have to be true in order for P and Q to be true, alright? So if we were to look at this, this is kind of, the conjunction is almost the same thing as if we drew our Venn diagram and we were looking at the and part, this. Alright, this is what it's representing, but in statements and propositions, alright, in words. Alright, but this is what it's representing. So if we had P and this is Q, this is what they're actually looking for. Alright? Alright, disjunction meaning or. Alright, notation for disjunction is the letter V. Alright? So P or Q is true if and only if P is true or Q is true or both. Alright? And let me just quickly draw a Venn diagram to represent this. And this is something you guys should already know. If we have P over here and Q over here, P or Q would be everything in between. Alright, so just keep that in mind when we do our truth table. Right? So let's look down here. We have P is true or Q is true or both. If P is true, Q is true, then this has to be true, right? If P is true and Q is false, then this also has to be true because one of them's true. If P is false and Q is true, then this has to be true because this one's true. If these are both false, then this has to be false, right? So again, if P is true or Q is true or both, and then it's going to be true. So it's either one or both. All right. So this was both true. This was one of them was true, so it's true. This was one of them's true, so it's true, and the last one was false, so it's got to be false. So again, pause you guys and copy all this down because it is very important that you guys know this. They will not give this to you on the formula sheets. All right. So the last one is the exclusive disjunction. All right. This is an exclusive or, and this is the notation for that. All right, exclusive or. So P or Q is true if exactly one of P or Q is true. All right, so let's look at this truth table real quick, and let me just write this here. All right, so we're looking at the truth table, and again, true, true, false, false, true, false, true, false, right? And it alternates into a little pattern. If both are true, it doesn't really go along with this definition, so this is going to be false. So again, it's only exactly one. Alright, so if this is true and this is false, that's exactly one that's true, right? So that's true. If this is false, this is true, that's exactly one that's true, so it's true. If these two are false, then these are false. Right? Again, please write this down. If we were to put this in a Venn diagram, right, what they are asking for is only this section here and this section here. All right, in a statement they will write this as it's like a either P or Q, not both. All right, so remember that that's exclusive disjunction. But again, write all these truth tables down, write all the definitions down. These are very important. All right, do not forget that. And for the worksheet today, you guys are basically just kind of putting this propositions, the statements together and identifying all of them. You're not going to do anything with truth tables. You will do that with truth tables next class or next section. All right, guys. Good luck today. I will see you guys soon.